Okay, we will start where we have stopped yesterday. I think yesterday we were discussing the middleware layer of Bluetooth protocol layers. Okay, so in this we have discussed about the RF communication layer, sub layer. Okay, so which deals with the uh, physical things, radio frequency communication things of the Bluetooth communication. Okay, so generally it deals with the WAP protocol, wireless access protocol, and also with the object exchange protocol. So this we have discussed yesterday. Communication is taking place in the form of digital objects, and for this object exchange type of protocol, at the same time serial communication with the help of wireless access protocol is carried out in this sublayer. Okay. And we have also discussed about adopted protocols. So there are standard protocols which are used for internet communication, and these same standard protocols are adopted for Bluetooth. So some of the adopted protocols here are for a triple P protocol, which is point-to-point protocol. So when you are connecting the Bluetooth devices in point-to-point configuration, then in that case, if you are carrying out point-to-point communication, so in that case, point-to-point protocol is used. So that protocol is present in this adapted protocol layers, internet protocol and user datagram protocol, transmission control protocol. So all these are for internet communication and wireless application protocol, that is wireless access protocol. So both are the same. So they are used for wireless serial communication. Okay, so all these protocols, in short, they are used for internet access. So apart from this, there is SDP protocol. Meaning of SDP is service discovery protocol. Okay, so this takes care of services related to the device with which the connection has to be established. That means this protocol allows to discover the services of another Bluetooth enabled devices. So which services are provided to the device to which we are going to communicate. So this discovering the type of services uh, which are present in another Bluetooth enabled device is carried out with the help of this protocol, and hence it is called as a service discovery protocol. Okay. So it is very similar to your telephony control protocol. So in telephone control protocol also, the services which are applicable to the other device, those must be discovered, and for the same purpose this type of protocol is used. The same is used here. Okay, so telephone control protocol is also a protocol which is available along with this Sdp protocol. Apart from this, all operations are carried out by using AT commands. So AT commands are very important here, and AT commands, meaning of this is attention command, and a set of commands is there for telephone communication. So basically these are used for telephone communication, speech communication. So generally which are used in speech communication, the same commands are used here in Bluetooth also. Okay, so these are the command sets to operate the modems. A modem means modulator demodulator, which enables to connect to the internet. It provides the internet access. Okay, so to run this modem, AT commands are used. Okay, to grab the attention of the modem, attention commands are used. So hence they are called as attention commands. The last layer of this Bluetooth is application layer. Obviously, all application profiles are included here, and they allow user to interact with the Bluetooth application. So application layer acts as interface between your Bluetooth and the Bluetooth application. Okay, Bluetooth application and the user. Okay, Bluetooth application and user. So this application layer is responsible for that. So this is all about the layers which are present in the Bluetooth. Okay, so now once again we are going to see how these protocols are categorized. Okay, so we have already seen the different types of protocols, that is set of rules which are used in Bluetooth for establishing the communication between the devices, at the same time establishing personal area network among Bluetooth enabled devices. So these all protocols, those which we have studied, they can be divided into different types, and these types are core protocols. So in your Bluetooth, some protocols are core protocols, and these core protocols, they include your Bluetooth radio baseband, LMP, that is link manager protocol, L2 cap, that is logical link control adaptation protocol, and service discovery protocol. So these set of protocols, they are called as core protocols. So you have to remember this for MCQ. Okay, so you have to remember many things in this particular paper. So you need a practice. You have to read the subject many times. So that is what the solution is. Okay, so these Bluetooth radio baseband, LMP, L2 cap, and SDP protocols, they are called as core protocols. And some protocols are there which are used to replace the cable by this wireless link, and these protocols are called as cable replacement protocols. And in Bluetooth, the cable replacement protocols include your RF communication protocol, and that is radio front end component. So RF communication and radio front end component, both are the same thing. Along with this serial interface with wireless access protocol or wireless application protocol, WAP protocol. So WAP protocol and RF communication protocol, they are called as cable replacement protocol, because they are providing replacement to the physical cable. Okay, hence they are called as cable replacement protocols. This next thing we have already seen, adopted protocols. Okay, so these protocols are adopted from the standard models. Okay, and hence they are called as adopted protocols. And as we have seen, triple P, that is point to point protocol, IP, internet protocol, UDP, that is user datagram protocol, TCP, transmission control protocol, and WAP. So here you can see WAP comes under adopted also, and it comes under cable replacement also. So you remember this specialty of WAP here. So these are the adopted protocols, and another protocol which is nothing but command set of commands, which is called as attention command set. So this is used in Bluetooth protocol stack. Okay, so already we have seen the working of this core protocols already. So here you can observe once again recap of this radio. This is a physical layer. Okay, and this lays down the physical structure and specification, and it defines the air interface. It defines frequency hopping specification and modulation technique. So this already we have studied. Okay, so which frequency band is used here? ISM band is used here. So which type of access system is used here? FHSS, frequency hopped spread spectrum technique. And which type of modulation is used here? GFSK, that is Gaussian frequency shifting type of modulation is used here. So if you consider a baseband, which is a sublayer of your physical layer, and this protocol takes the services of radio protocol. Okay, and what it does, it defines the addressing scheme, frame format, timing, and power control algorithms. So this already we have seen. Link manager protocol, it establishes a logical link, and it maintains the link for establishing communication, and already the link is established by physical layer, but management of maintaining the link is carried out by the LMP protocol. Apart from this maintenance, LMP is also responsible for authentication of devices, encryption, decryption, and deciding the packet size. Okay, so you have to remember the functions. These are very, very important. So another layer, that is L2 cap layer and adaptation protocol layer. So this provides the adaptation between upper layer frame and baseband layer frame format. So basically it is acting as an interface for the frame formats, because the frame format of baseband layer is different from that of the layers which are present below. Okay, so this adaptation, that is conversion from one frame format to another frame format, is carried out by L2 cap protocol. And it provides support for two types of communication. One is connection oriented and another is connectionless communication. So both are supported by this L2 cap. And as SDP protocol, we have seen it takes care of service related things. That is, it sees the device information regarding the services hired by it, so as to establish the connection between the Bluetooth devices. Okay, so these functions are very important. You have to remember those. Very micro things are there. You have to remember these for what is known as your MCQ type of nature of your examination. Now, let us go to another point which is given in your syllabus, and that is Bluetooth frame structure. So as data is transmitted in the form of frames, so what is the frame structure that need to be studied? Now here you can observe a complete frame which is basically divided into three fields: access code, which is of 72 bits, header, which is 54 bits, and data. It is variable and it varies from 0 to 2744 bits. Okay, so variable data length is allowed here. Now this header portion is amplified here, and here you can see again these 54 bits are divided into three different slots. Same slots are repeated. Each slot is of 18 bit width. So such three slots are present in the header. Okay. So one consists of 3-bit address, uh, 4-bit type field is there, 1-bit F field, 1-bit A field, 1-bit S field, and 8-bit checksum field. Okay. So this is what is present there in the header. So this whole is the structure of the frame. So let us discuss the functioning of this frame format. Okay, so as you can see here, the access code is of length 72-bit field, and what it consists is, it consists of the synchronization information, and this synchronization information is used to identify the master. Okay, we have seen in Bluetooth there is a network which is called as piconet, and piconet consists of one master and there may be up to 7 slaves. Okay, so to identify the master, this 72-bit field synchronization bits are used. Okay. कोणतरी आलेलं दिसतंय. एक minute, huh? Sorry. So let us see again what is the function of the access code. Access code contains the synchronization bits. to identify the master in Bluetooth network. Okay. Uh, Now coming to the next field, which is header. Uh, as I told you, header consists of 54 bit, and these 54 bit are divided into three 18-bit patterns. Okay, and each 18-bit pattern have these following fields. Those we have seen, out of which the first field is address field. This is of length 3 bit. Okay, and as I have told you, we can connect the 7 slaves to the network, Bluetooth network. So these 3 bits are used to identify these slaves. So the maximum number is 7. So 1111. Therefore, 3 bits are assigned for this to identify the address of the slaves which are present within a particular piconet. Okay. So address field will identify the slave. Okay, so you have to remember this. Then next type of the field is type field, and it is 4-bit field. Okay, so what it does is it identifies the type of the data from the upper layer. So which type of communication is going to be there? This is identified by this 4-bit field. There are three types to be identified here. One is asynchronous connectionless communication. So as I have told you, there is no need to establish communication before data transfer or packet transfer in this type of communication. So this is called as asynchronous connectionless type of communication. Okay, so this can be identified by this 4-bit field. SCO is a synchronous connection oriented communication. Here, the connection between two devices is established first, and then the data packets are transmitted or exchanged between the devices. Okay, so this is a second type which need to be identified, and third, no operation, that is pole or null. So when data is not present there, it is identified by pole or null. Okay, so these three types of communication or types of data are identified by this type field, which is of length 4-bit. Now, let us go to the 1-bit fields which we have seen in the format. And these 1-bit fields are, as you can see, there is one bit called as F. F means flow control. It is basically used for flow control, and it indicates overflow. So when F is set to 1, it indicates the overflow, and device cannot receive more frames. Okay, its capacity is over. That is what is indicated by this particular bit. Bit A, as it indicates, as its letter indicates, it is acknowledgement bit. Okay, so it acknowledges that the frame has been received. Okay, and this bit is activated at the end of the frame. At the end of the frame. The third bit that is shown here, it shows the sequence number of the frame, and this sequence number of the frame that is detected for retransmission. Sometimes what happens during communication, some error may occur, and if error occurs, the retransmission is requested in this case. So in case of retransmission, the frame which requires retransmission is denoted by this S field. Okay, so this S field function is like this. Now after this, you may find checksum field, and it is 8-bit field. So this checksum is a type of error detection technique. So it sees whether the error has occurred or not. It will form a sum of the data, and this sum will be checked for the error. And if error occurs, the retransmission of the packets is requested. Okay, so that is what is followed in Bluetooth communication. Now, after this, we have data field, and here in the data field, we have a variable length starting from 0 to 2744 bits. Okay, so it contains the actual data. Okay, so now as you can see, there are two formats of frames. One is your basic Bluetooth frame format, which now we have discussed. There is one more Bluetooth frame format, which is called as enhanced data rate frame format. So this deals basically with the enhanced data rate. Okay, so apart from the basic frame, it consists of two more fields in enhanced data rate Bluetooth frame. And these two fields are a guard field and trailer field. Okay. So here you can see the guard field is of 16-bit wide, and it consists of synchronization pattern. And this synchronization pattern helps to enable switch to the higher data speed. Okay, and trailer bits are 2-bit field, and they denote the end of the data field. So end of the data field and higher data transmission field is denoted by guard field and trailer field, as you can see here. Uh, this figure shows you this is what is your basic data format and basic frame format, and this is your enhanced data rate frame format. So what is added here is for data, two things are added at the start and at the end. At the start, guard synchronization bits are present, otherwise else remaining remaining things are same. Okay, and at the end trailer 2 bits are there. And here you can observe the data length variable from 0 to 8184. 0 to 8184 bits. So this length is pretty wide, and it can allow data rate 2 times or 3 times more than the basic data rate of the uh, Bluetooth. Okay, so this is what is the difference between enhanced data rate frame format and basic Bluetooth frame format. Now let us go to applications of Bluetooth. So all of you know this. There is no need to discuss about this, but still here I'm displaying it on the screen. Okay, so you can use Bluetooth for your laptops, notebooks, wireless PCs, mobile phones, personal digital assistants, printers, headsets, personal area networks, even local area networks. They are used to transfer data files, videos, images, MP3, MP4 format. Okay, wireless peripheral devices like mouse and keyboard, they can use Bluetooth type of communication. Even data logging equipment, they can be enabled with Bluetooth technology. So for sensor devices also to transmit the information, uh, the short range Bluetooth can be used. Okay, but the special type of short range communication is used for sensors, and it is called as Zigbee. So we are going to study Zigbee later. In the next lecture, we will study about Zigbee. Now here we are completing with the Bluetooth, and let us now go to a smaller part because less time is there. And first we will go to a smaller part of your syllabus, which is nothing but your RFID. Okay, so first we will complete up RFID, and then we will be moving to Zigbee short range communication. Okay, so here you can observe something on screen. Can you read it out? What is present on the screen? Yes, what is meaning of this RFID?
Radio frequency identification.
Yes, it is a kind of identification which is using the radio frequencies. So it is application of the radio waves. Okay, to read and the capture information which is stored on the tags, and these tags are fixed to objects or animals or even books, etc. Okay, depending on its application, even human beings in some case. Okay, so this is automatic detection and tracking and information collection and identification system, which is carried out with the help of radio frequency waves. So which is called as RFID. Okay, so now let us go to the next part of this. Now what you can observe on the screen, can anybody tell me what you can observe on the screen? Yes. Yes, 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 tell me.
RFID ची working principles.
RFID working principle. So you can observe the diagram here. Two diagrams are shown here. So here, which components you can observe? This small part is called as tag or transponder. Okay. There is reader or interrogator. Okay. Antenna is connected to it, obviously, and this interrogator is connected to computer. That means basically there are three parts of radio frequency identification system, and these three parts are tag, reader, and computer. Okay, so here the same thing you can observe. The object is shown over here, and this object is fixed with the tag. Okay, so this tag is embedded in the label of the object. So there is a reader, and this is connected to the database, or you can say some middleware of your uh, RFID system, and this information is again connected to other databases through the network, basically through the internet. Okay, so this is what is present there. अजून कोणतरी आलेलं दिसतंय. एक मिनिट मला अटेंडन्स घेऊ दे. रोहित, उशीर झाला रे रोहित. Okay, so let us discuss about each component here. Okay, so tag is a device which consists of information about some object, and along with it, it may have transmitter and receiver and antenna onto the small chip. Okay, depending on whether it is active type of tag or passive type of tag. Okay, and this tag is responsible for transmitting information in the form of radio frequency waves. Okay, so this is what tag is. So what tag consists of? Tag consists of a memory which stores the information about the object and identity about the object, you can say. It consists of transmitter, receiver. It may consist of transmitter, receiver, depending on its type, and it consists of antenna. So it is a radio frequency device which can transmit the identity or information about the device or object, you can say, which you are going to identify. Okay. The second uh, type of device is called as a reader. Sometimes it is also called as an interrogator. So what this reader consists of, reader again consists of antenna and transmitter receiver. Apart from this, it has what is called as DSP chip, digital signal processing chip. It is going to process the information and apply it to the computer. Okay. So what RFID reader does, it captures the information which is in encoded form on the tag. Okay. So it is a two-way radio transmitter receiver. Okay. So it is capable of emitting signal for the tag, and at the same time it is capable of receiving the signal from the tag. Okay. So both things it is doing. It is transmitting the signal, at the same time it is receiving the signal. Uh, Actually, what happens initially, reader sends a signal to the tag. Okay, and tag responds to the signal which is sent by reader, and this responds the reader signal by sending information which is embedded within it. Okay, so this information is then captured by your reader, and this captured information is processed with the help of DSP processor chip, which is present within a reader, and then it transmits this information to RFID computer program. And this RFID computer program then performs a necessary processing on it, and this processed information now will be directed to the intended database through network. So this is what is happening in case of RFID system. Okay, so elements of RFID system, they are important. You must know the what is the function of tag, what is function of reader, what is the function of computer in RFID system. As far as your examination is concerned, you must know the block diagram also. Okay, so now let us move ahead. Okay, so here you can see what is happening. So in this, if you are observing what is happening in the RFID system, tag is there, scanner means reader is there, and then server, that is your computer is there. So information is transmitted to the reader, and from reader it is transmitted to server. So as you can see there, there are two types of uh, tags present. These two types of tags are called as passive tags and active tags. Okay, so passive tags, they use radio wave energy of reader to transmit its ID to the reader. So they are not capable of transmitting radio waves. Passive tags, they are not capable of transmitting radio waves. They are using the radio waves which are transmitted by reader. And by using these radio waves, it is going to transmit identification or information about the object to the reader. And active tags, on contrary, they have onboard battery, and they have onboard transmitter, and they can transmit their identity periodically. So they are capable of transmitting. They are equipped with onboard battery. Okay. So in passive tags, there is no presence of battery, there is no presence of transmitter. But there are some passive tags which are also battery operated, but there is no transmitter within them. Okay, some battery assisted passive tags are also there. Okay, so according to its readability, we can categorize radio frequency identification tags in these types. For example, read-only tags. The type of memory which is present in the tag is read-only type of memory. Only factory has assigned identity on this memory, and this cannot be changed. So these type of tags are called as read-only tags. There are read-write tags. Read-write tags, on this read-write tags, the data can be written and even read. Okay, so user can change the data within the tag. Okay, so this is what is read-write tag. There are also tags which are called as field programmable tags. Okay, and these field programmable tags are written once by the system. Okay, so once it is written by the system, afterwards they can only read multiple times. So written once and read multiple times. So it is also called as worm type of tag. Worm, W